Hello guys, Winston here. You know that feeling when you're the most tech-savvy person in the house, and anytime someone has a computer problem, it's going to be your problem? Well, when you have a CNC or even a 3D printer, if a family member or friend wants something made, you almost always end up getting a call. Today's project, an epoxy inlay charcuterie board, is a prime example of that familial burden. Here's the backstory. My sister-in-law assembles a mean charcuterie board. She knows all the best cheeses at Trader Joe's, there's always a good dip or spread to be had on the side, and she's got that weird salami rose thing down pat. But she's typically made her edible arrangements on a pretty basic board that's always a little too small, questionably flat, and finished, or rather unfinished, in a way that probably won't stand the test of time. During an airing of culinary equipment grievances at last year's family holiday get-together, my wife was all too happy to suggest that I could easily solve her sister's charcuterie shortcomings. And I know it was a well-intentioned comment, but what's that saying? The road to hell is paved with the time that's supposed to be dedicated to other projects? I don't know, something like that. Anyway, the bottom line is I have to make a charcuterie board now, which is not really something I've ever had an interest in making, but hopefully we can have some fun with it. Now, I'm going to tackle this project like I would any other project, by treating it as an engineering exercise. Let's start by identifying some stakeholder requirements. Objective 1, food containment. The primary function of a charcuterie board is to hold food securely and keep stuff from falling off. That usually means a lip. Not a juice groove, a lip. Objective 2, ergonomics. On a large board, especially a heavy one, it's essential that there be an easy way to pick it up. A common way to do this is with a groove in the side of the board, cut with a cove or roundover bit, and this is fine. It's actually great on a cutting board because it's an orientation agnostic feature. You can still use either side of the board. But these kinds of features create thin areas in the board, places that over time may be more likely to crack or split. We're not making a cutting board though, and since we're personalizing this charcuterie board, the top face will always be facing up. This means we can cut handholds as an overhang in the board. This will funnel fingertips in more naturally and eliminate those thin areas I found objectionable before. And the last element to a memorable charcuterie board, which I touched on earlier, is personalization. That's objective 3. The easiest way to do this would be with a laser. Just burn initials or a name into a board and call it a day. And that is a fine way to customize a board. But to me, it feels low effort. It looks kinda flat and it won't set your work apart from stuff on Etsy. You could do a wood inlay. That's what Kevin did on the Carbide 3D channel, and I really do think it adds an interesting, classy character to a board. But in this case, I don't feel like this matches the vibe I'm going for. I want this charcuterie board to be a centerpiece, to have a bold splash of color. And to achieve that look, I'm going to do a multicolored epoxy inlay. We'll assume these requirements don't need to be validated. Let's skip to designing and developing this charcuterie system. A safe starting point is a rectangle. You can't really go wrong with this form factor. And on any wooden shape you're cutting out, corner radii are always great. They prevent chip out at the corners and they make the finished product more impervious to dents and dings from being bumped or dropped. The corner radius I'm using on the outside is derived from the cutting radius of the bit I'm going to use for pocketing the food holding depression of my board's top face, plus the width of a lip. Speaking of that food basin, it's going to be pocketed down 5 mm. The bowl bit I'm going to use to cut it has a corner radius of 6.35 mm, and I don't want the lip to go completely vertical. Handholds on either end of the long axis should be generously sized so you can find them without looking and grab them even if you have ogre hands. For the decorative design, I started with an SVG I bought online. The amount of time it would take me to come up with something better is worth far more to me than $3. And yes, although I do prefer to work in Fusion 360 and I'm illustrating some of the design elements of this board in Fusion, the majority of the toolpaths I employed on this project were driven by Carbide Create. For an artistic application like this, the workflow is actually very easy and effective. If you want to take a closer look at how I set up my project file and toolpaths, I'm going to put together a simplified example file using a not paid for vector file and upload it to CutRocket. But for the sake of time, let's just skip over the design phase of this project and go straight to the fun part, which is figuring out the epoxy inlay. Doing an epoxy inlay is fundamentally as easy as making a pocket and pouring in epoxy. But depending on how you want to do it, there can be some complications. If your pocket doesn't have any sharp corners, you can use a regular square end mill and make a pocket to pour your epoxy into. That's the best case scenario. But if you have a design with pointy or thin sections, you'll want to use V-carving. If you're doing a single color inlay, things are still straightforward. Select your contour, apply a V-carve or advanced V-carve for conservation of epoxy, pour epoxy, and profit. But a multicolor inlay not only requires some careful sequencing of cuts and pours, but some careful thought in picking vectors to define your toolpaths and pockets. Let's look at a basic example that has colors within colors, a simple bullseye. Ignore the fact that you could do this with a flat end mill. If I cut the red areas with a V-carve, pour epoxy, then cut the white areas and pour more epoxy, the cross-section of this piece will look like this. At the surface, the colors all theoretically line up, but if I cut even a fraction of a millimeter too deep when I'm surfacing off excess epoxy, or maybe I hand sand just a little too long, the underlying wood substrate is going to peek through from between the colored sections. Machining an inlay this way is not fault tolerant. The better way to do this is to create a foundation with either the predominant color or the color of a bordering element, and then pocket out individual colors. For the bullseye example, that means filling the entire circular area with red, then coming back to trim out the cavity for the white epoxy. It'll use up a little bit more epoxy, but now, no matter how you surface this piece, there will always be a seamless gap between the colors. For my tropical design, that means the entire area of the inlay gets pocketed down first and then flooded with black epoxy. Then I'll come back and fill in each of the smaller pockets with the correct corresponding color. Now, this is all great in theory, but until I have some stock material in hand, this project's not going to leave the digital design phase. Since I don't have room for a nice table saw in my one-car garage shop, doing the stock prep to glue up a cutting board or charcuterie board from scratch isn't happening. But one day, while I was perusing my favorite deal-finding website, a listing for a 23 by 18-inch acacia cutting board caught my eye. It was on clearance at Walmart, and the price, $15, seemed like a steal, so I bought 3. At first glance, these are pretty sturdy boards with a nice-looking factory finish and handholds, but there are also some areas where corners were clearly cut in this product. Not surprising for something mass-produced for low cost, however, I'll touch on these issues when they become relevant. What I need to do now is nail down the size of the final board. 23 by 18 is just ridiculously large. My sister-in-law suggested 18 by 12 inches, and she didn't care about the grain orientation. That was great news for me, since that meant I could chop this board up in a way that left a potentially usable offcut. And lacking a table saw, I opted to use my CNC to cut this board down to size. I made a simple toolpath that followed a straight line and set that loose on my board. After the first pass, I tweaked my zero position until I had just barely cut off the cutting board's original handhold. And after that was successful, I ran a second toolpath that trimmed the board at a distance of 12 inches and 3 millimeters past the final cut. That extra material is to give me some margin for error in aligning the final profile cut. Next, I realigned my cut-down stock to my CNC's bed. I did this visually referencing some lines I'd previously engraved in the MDF wasteboard. I'm using both double-sided tape and clamps here. At some point, I'll need to trim around the perimeter of the board, so that means the clamps need to come off, but for every other operation, I'd like some extra insurance. I've been known to skimp on double-sided tape before. For zero setting, I'm using a 1/4 inch end mill and jogging it until it just barely touches the left and front edges of my stock. Then I can tell carbide motion that I'm 1 end mill radius from the real X or Y 0 point. Program number 1 roughly pockets out the basin on the top of the board, leaving a millimeter of extra material on the floor. This will make things easier for the V-carving toolpath later, less material to get through, but it also leaves a skin of material on top that will hopefully shield the rest of the board from any epoxy pigment seepage, something I learned was a risk when I did a small-scale test prior. Next, in a different program with the same zero, I ran a profile cut around the perimeter of the final board. I decided to do this step earlier than I'd originally planned, that way if I screw up, it won't be after having invested many hours into this piece. As you cut into wood, you release internal stresses and expose it to different environmental conditions. As soon as you cut into a board, you can't trust it to stay as flat as it was before. This charcuterie board blank could slowly peel itself away from the double-sided tape in MDF, so I had to work fast. Fortunately, I used enough double-sided tape here to get through this step, and using a down-cutting end mill certainly didn't hurt either. Next, I reinstalled the clamps and got to work on the inlay. First up is the pocket that's going to receive the black epoxy. Since this is going to be a pretty expansive area cleared, I'm pairing my 60-degree V-bit with a 1/4 inch flat end mill for pocket clearing. This combo made quick, clean work of my first V-carved pocket. Now, my small-scale test told me that I should be careful about tinted epoxy bleeding into end grain, so before I mix up the big, in air quotes, epoxy pour, I'm going to mix up a bit of penetrating epoxy to seal the grain. This stuff tends to run thin to soak into the wood fibers, and I'm applying it with an acid brush. 24 hours later, I'm back and ready to pour my black epoxy. I'm using both mica powder and dye to try and get a nice opaque layer. As a side note, I decided to give Carbide Create's toolpath volume estimate feature a try. It said I needed about 3 fluid ounces of epoxy, and it was nearly spot on. However, because you might always leave some epoxy in your mixing vessel and you need a safety margin, I'd recommend making about a 1/4 ounce or maybe a couple % more epoxy than you need. Plus, I find that by leaving about an 1/8 inch of epoxy in the bottom of the mixing cup, it's much easier to pop out all the residue in one piece. Better than turning this cup into a single-use vessel. You just need to squeeze around the circumference of the cup to separate the cured film of epoxy around the walls, and then start working the air gap around the puck of epoxy in the bottom. Anyway, a day later, I'm back to cut out the pockets for the colored epoxy. Now, although I was emboldened by my small-scale test, I will admit I probably rushed this step. I was probably doing this only about 22-ish hours after I poured the first layer, and on top of that, I learned that penetrating epoxy can sometimes be thinned with solvents, and if you don't let it really cure, those solvents can slow down the curing of follow-on layers. I know of people who will let epoxy cure for 2 or 3 days before doing anything with it. So, although I was able to cut my V-carved pockets into the black epoxy, the surface finish wasn't great. The soft epoxy shavings clung to the surface and needed some mechanical encouragement to be removed. Side note, I'd like to mention that this has nothing to do with any deficiencies in Total Boat's product. I've used this stuff several times in the past with great results. I just needed to have a bit more patience here, especially since I was using a product that was a couple years past its best by date. #hoarding problems. Now, to get some color into this board, I mixed up a batch of green and red epoxy, lighter than I'd done in my small-scale test, which felt a bit too Christmassy, and then I poured both of them into the cut pockets. If you want this process to be foolproof, I'd recommend just cutting and pouring one color at a time to avoid the risk of neighboring colors bleeding over. I, unsurprisingly, lacked patience, putting my faith in the steadiness of my hands and the power of surface tension. And although things worked out for the most part, I did need to go in with a syringe in a couple spots to extract some epoxy that spilled over between compartments. I gave the board 2 days to cure this time, and then came in with a bowl bit to shave down the epoxy and leftover stock. In Carbide Create, I had this tool programmed in as a simple 3/4 inch diameter end mill. Nothing fancy with corner radii in the definition. I know some people get hung up about not being able to define tools with 100% accuracy and inputting corner radii, but with just a little imagination, you can pretty easily predict how a cut with this tool is going to come out even if the simulation doesn't show it perfectly. Now, assuming your spindle is trimmed pretty well, it should only take a little bit of sanding to get things looking consistent afterwards. And because we nested the epoxy pockets in the way we did, even if we sand a little deeper than planned, the colors will still look perfectly seamless. For the handholds, I flipped the board over and used a little bit of Fusion 360 magic to cut out some open pockets with slightly tapered walls. And that was the last of the machining. More than a few times in the past, I've looked at a finished piece and regretted not having taken more time in sanding or looking for blemishes. If this board were for personal use, my standards would probably be a bit lower. As a hobbyist woodworker, though, the truth I've come to realize is that you'll never regret taking more time to get things right. In going over this piece with a fine-tooth comb, I did uncover some underlying defects in the parent material. First of all, take a look at the construction of the board and how it's made from multiple strips of wood. These strips generally come from very close to the center of the tree, if not the actual center, judging by the tightness of the ring pattern. These are the cheapest cuts of the tree because they're more prone to warping. That's a prime example of where costs were cut and why I methodically surfaced my board blank before starting. Another sign of lapses in craftsmanship are some of these glue joints. I don't know how large the glue-ups are at the factory that these boards are cut from, but they're large enough that voids are allowed to form between strips of wood that might not be perfectly square. I also found a spot where it looked like I happened to cut through the board in just the right spot to uncover a tunnel bored by an insect. For this spot and some small gaps in the end grain structure, I mixed up a small batch of clear epoxy to fill these voids. And once the epoxy was set, I sanded the edges smoothed and moved on to the finishing process. For a food-safe coating, I'm using Emmett's Good Stuff. I think it's some form of urethane gel. It wipes on easily and creates a nice smooth look, not too shiny, not too matte. I applied several coats for good measure. This stuff can be pretty amazing for small projects, but it can also be problematic for larger projects because it starts drying quickly and gets sticky, making it hard to properly buff each layer into a streak-free coating. So charcuterie board, great, but an 8-foot dining table, maybe not. I'll also note here that part of the reason the epoxy inlay isn't as glossy as it could be is because I read somewhere on the internet that sanding with too fine a grit can weaken the bond between epoxy and finishes, so I stopped at 400 grit. Once everything had cured for several days, I added rubber feet as a finishing touch. These are just adhesive, although they have a fairly large surface area. If they ever do fall off one day, I can just replace them with screw-mounted feet, but my thought about using adhesive-backed ones was that it'd be harder for moisture to weasel its way in between the rubber and the wood. For consistency and symmetry, I made a 3D printed guide for installing the feet. And that wraps up this board. Now there's nothing left to do but turn over the proverbial keys and enjoy some finger food. Now, was this a crazy TikTok-worthy heirloom-quality transformation of a $15 cutting board? Probably not. But I did appreciate that with a fairly modest technical skill set, you could take a simple off-the-shelf product and turn it into something that friends or family members would genuinely appreciate. Anyhow, that's all I have for today. Real quick before I close out though, I just want to say I'm going to be attending the Texas Woodworking Festival in Austin, which is happening on September 13th and 14th. I'll be representing Carbide 3D at their booth, and I'd love to say hi and swap stickers with any of you who will be there. I want to thank you all very much for watching. Didn't think a charcuterie board could get me monologuing for over 15 minutes, and I'll be back soon with more CNC projects and DIY nonsense.